Okay, this is chapter 13 and 13.1. 13.1 is about the functions of two or more variables. Two or more variables. Now, maybe you know about the function, the definition of a function in one variable system. Okay, what is function? That you have some input value and there will be some output value of this one. That for any input there must be one output. Okay, so unique output. So how you define, if I say that there is a function of two variables. Okay, a function f of two variables, this is f of two variables x and y, is a rule. You can't hear me, Faris. um can you hear me, other students? I don't know about the other student, but Faris, I think he have a problem with the voice. Is a rule that assign a unique real number f of x y to each point x y in some set d in the xy plane. Okay, so that the meaning is same what you have studied before. The meaning of this function is exactly same. What does that mean? That you have to choose, these are the two variables. Okay, if you assign a unique real number, if you assign unique real number to x and y, there must be a unique value for the function. Okay, that belongs to the set d in xy plane. So that is called a function, and that must be a real number. Okay, so similarly you can define for the three-dimensional case. Okay, what is the definition for three dimension? That a function f of three variables x, y, and z is a rule that assigns a unique real number x, y, z to each point in x, y, and z in some set d in three spaces. In three spaces. Okay, so this meaning and the second order meaning is same. If you have two variable function, if you have three variable function, or one variable function, the meaning is exactly same, but it depends on the three variable system. Okay, let me give you one example from the first variable, from the one variable function. That f of x is equal to x square plus 1. This is one variable function. Okay, if I assign any value in the x, for example I assign the value 1, that will give me one value which is equal to 2. Okay, for one value of x there will be the one value of y. This is the definition of the function. For example, if I take a function of two variables, x square plus y square, for example 2x, if this is a function, if I assign a point, because in two dimensional means, in one dimension means only point you choose at a line. In two dimensional or two variable means you have to choose a point. For example, I choose a point here, so that point contain x and y. Okay, here if I choose a point that contain only one point, which is x. If I choose in this case, that is x and y, for example I choose 2 and 3. If I substitute the value, that will give me what? 4 plus 9 plus 4, 8 plus 9, which is equal to 17. Okay, for one point I will get the one value of the function. Okay, similarly you can, if you choose the variable of three, function of three variables, f of x, y and z, that is x square plus 2xy plus yz or plus 1 something. Okay, that value must be, for example if I choose one point, you have to choose one point and the result must be a number, must be a real number. Okay, if I choose one point here in x, y and z, okay, so if I choose any point, for example 1, 1 and 3, so 1 square plus 2 into 1 into 1 plus 1 into 3 plus 1, that is equal to 1 plus 2 plus 3 plus 1, which is equal to 4 plus 3 is equal to 7. Okay, so any point you choose, that will give you one result. So this is the definition of a function. Okay, if you choose any point, that will give you one result. And what point you have to choose? When you talk about the one dimensional, you have to choose one point in a line. Okay, and that line is x. If you choose one point in two dimensional case, it means you choose one point or any point in the pair of x and y. If you choose in the three variable system, you have to choose one point and that point must be x, y and z. X, y and z. Okay, any point you choose. So this is the basic definition. Now I will give you one example that how you can find the domain of the given function. Okay, for example, what is the example? That let you have a function of two variables, f of x and y, which is equal to square root of y plus 1 plus natural log of x square minus y. This is a function. You have to find the value of the function e n 0 and sketch the natural domain of function. Sketch the natural domain of the function. Okay, now what we have to do? First we have to find the value of the function at point e and 0. The point is given. Okay, it means x you have to choose e and y you have to choose 0. So what will be the function become 0 plus 1 plus natural log of e square minus 0, which is equal to square root of 1 plus natural log of e square, which is equal to 1 plus 2 into natural log of e, because you can write the power in the front, and natural log of e is 1. 1 plus 2 is equal to 3. Okay, so it means this point give me some value. Now talk about the domain. To find the natural domain, to find the natural domain, you have to choose term by term. Okay, this term and this term, we have two terms. For the natural domain, we observe that this term y plus 1 is only defined when it is defined. Anybody can tell me? Is defined only when y plus 1 should be greater than or equal to 0. Very good. Because if it is less than 0, it means it will give you the complex number. Okay, so it must be greater than 0. So you can write, if it is greater than 0, implies y should be greater than or equal to minus 1. Right? Is this clear? Now for the second term, while the second term is what? Natural log of x square minus y. Minus y is only defined, and you know, for the natural log of 0 is undefined. The natural log of negative values are undefined. So it must be greater than 0, not equal to 0. Is only defined when x square minus y should be greater than 0. Okay, so should be greater than 0 means implies x square should be greater than y. So how many inequalities you have now? You have two inequalities. One inequality is this one, another one equality is this one. If you combine that, thus the natural domain will be y is greater than or equal to minus 1, right? If I can I write like this one? Y is greater than equal to minus 1, yes, and y is less than x square. So I combine this inequality. So if any x and y satisfy this inequality, this is the domain of the function in xy plane. In xy plane. Is this clear? That y should be greater than or equal to minus 1 and less than x square. So this is the domain of the function, given function. Okay, so this is about the two-dimensional two variables. Now if you have a question about the three variable, how to find the domain for this one? For example, I give you another example. that let f of x, y, and z, three variable function, okay, which is equal to, for example, square root of 1 minus x square uh, minus, this is not plus, okay, this is minus y square minus z square, okay. This is, I write again, 1 minus x square minus y square minus z square, okay. And find, you have to find the point, find f of 0, 1 divided by 2, and minus 1 divided by 2, and also find the natural domain of the function, okay. Now for the first point solution, you have to first find the point, find the value for this point, 0, 1 divided by 2, and minus 1 divided by 2. That is equal to square root of 1 minus 0 square minus 1 divided by 2, okay. Why? This also have an option. This is the new blackboard, whiteboard. You can erase this one. Before we don't have these options. 1 minus y square minus this one. So here I will write 1 minus 0 square minus 1 divided by 2 whole square minus 1 divided by 2 whole square, okay. When you simplify, what you will get, square root of 1 minus 1 divided by 4 minus 1 divided by 4, which is equal to square root of 1 minus 1 divided by 2, which is equal to square root of 1 divided by 2. So square root of 1 divided by 2 is a real number. Now for the natural domain, for natural domain, we have to choose, for example, if I, this is the term, okay. If we choose this one, it's only defined, this is only defined when, anybody can tell me, this is only defined only when 1 minus x square minus y square minus z square should be greater than or equal to 0. Yes. So this is only because this is a square root, and square root is give you the real value, square root give you the real value when the square root have a 0 or greater than 0 number. So this is the real number, and if you want to write in a good way, you can write x square plus y square plus z square is less than or equal to 1, okay. And this equation is the equation of the sphere. For example, this is in the three-dimensional case, okay, and this is the sphere, and you can less than 1, This is 1, this is 1, and this is 1. Less than 1 means inside the sphere, not included the boundary. Boundary is not included. This boundary, it's not included in this region. So this is the domain. Got it? Just I explain graphically. So this is how you can find the you can say the domain of any function. It's given to you either in the 2 variable function or 3 variable function. Okay. Okay, now the next topic is about the continuity, limit and continuity. Okay, this is all about 13.1, that how you define a function in 2-dimensional, 2 spaces or 2 variables and 3 variable system. Now 13.2, it's about limits and continuity. Okay, how you define limit along any curve. Limit along the curves. You define the, you know the real, you know the definitions of limit and how to solve the limit when you have one variable in calculus 101. But here we have to find the limit. You have to find the limit when you have more than one variables. Then what is the method to find that? So for example, if C is any smooth curve, okay, any smooth curve in either 2 space or 3 space, okay, 2 space or 3 space, that is represented by, that is represented by the parametric equations, okay, or just an equations in terms of one variable, that x and y in 2-dimensional, you have to represent that x and y in terms of t, in terms of t. This is for the 2-dimension. Or for the 3-dimension, you choose x is equal to x of t, y is equal to y of t, and z is equal to z of t. What does that mean? That how many variables you have to choose them in a one variable. So the 2 variable, convert it into the 1 variable, 3 variable, convert it into the 1 variable system, and 1 variable we already know from calculus 101 that how we solve the limits. Okay, so the main change for finding the limits is that how you can change the limit of any function from the 2 variable function into the 1 variable function. Okay, so how we can change that? If we choose any point x naught, which is equal to x into t naught, and similarly you can find y naught, which is equal to y into t naught, and you choose z naught, which is equal to z into t naught. And how you can find the limit? By representing this value, limit x and y approaches to the point which is x naught and y naught along any curve, along for example curve C, okay, and the function is given f of xy. So this is equal to what? This is equal to, you have to change the limit in terms of t to t naught, okay. The function is changing into just the variable of t, okay, and you have to find the limit. This is in the two-dimensional. Okay, how about the three-dimensional case? This is in the three-dimensional, that limit x, y, and z approaches to any point which is x naught, y naught, and z naught, and we talk about any curve along the any curve, and you have a function of three variables. You have to just change the limit into the one variable, which is t approaches to t naught, and you have to change the function of each variable in terms of t, in terms of t, and you solve it. Okay, so this is the definition we use to find the limit of any function which is either two-dimensional or three-dimensional, or two variables or three variables. Okay, now give you one example so that it will be clear that how you change the variables, two variables, into the one variable. Okay, so just see this example. Example is that let the function is given, for example f of x is no f of xy. Function is given f of xy, which is equal to minus xy divided by x square plus y square. Okay, uh, you have to find the limit, find the limit of f of xy as x and y approaches to one point which is 0 and 0. Okay, x and y approaches to one point which is 0 and 0 along which curve you have to find the limit along x-axis. Okay, b you have to find along the y-axis. C you have to find along the line which is along line y is equal to x. Okay, and D you have to find along the line y is equal to minus x, and E you have to find along y is equal to x square, which is parabola. Okay, now how you can find the limit of this function? Now see the part a part, you have to find the limit along the x-axis. The x-axis has parametric equations equal to what? X is equal to t and y is equal to 0, because we only take the x-axis. X-axis means other axis is 0, and we are talking about only two axes, x and y. So x-axis is t and y-axis is 0. What is the parametric equation? What is the parametric equation? X is equal to x naught plus at, right? So a is any number, for example we choose 1. Okay, and x naught, it's given that it is equal to 0 and 0. Okay, so that's why the parametric equation is x is equal to t, y is equal to t with 0 0 corresponding to t is equal to 0. Okay, so how you can find a limit x and y approaches to 0 and 0 along x-axis. Okay, and the function is given. What is the function? Function is this one, that is minus x y divided by x square plus y square. Now this is equal to what? Limit t approaches to 0. Okay, and now you have to substitute x is equal to t and y is equal to 0. So if I substitute the value here, minus t, y is 0, divided by t square plus 0 square, which is equal to what? Limit t approaches to 0. 0 multiplied by t multiplied by minus 1, that is 0, and divided by t square. 0 divided by t square is equal to what? 0. And what is the limit of 0? That is 0. So this is the limit of this function. Is this clear? What you do, you have to first find the parametric equations, and which you find the parametric equations, you have to just replace that in terms of the function. Okay, similarly, if we find for the y-axis, what are the parametric equations? The parametric equations for y-axis will be x is equal to 0 and y is equal to t. Okay, uh, with 0 0 corresponding to t is equal to 0. Okay, so apply on the limit x y approaches to 0 and 0, and here you have to write along y-axis, and what is the function? Minus xy divided by x square plus y square. Okay, this is the function. So this will become limit t approaches to 0. Now substitute the value. What is the value of x? That is 0. What is the value of y? Which is equal to t. 0 square plus t square. When you simplify that, you will get what? 0 divided by t square, the same result. Okay, so that is equal to t approaches to 0, 0, which is equal to 0. Okay, now the third part is C part is along the line y is equal to x. Okay, so along y is equal to x, what are the parametric equations? Parametric equations will become x is equal to t, y is equal to t, right? Because they are both same, with 0 0 corresponding to t is equal to 0. Okay, so limit x and y approaches to some point which is 0 0 along y is equal to x, and here you write function which is x square plus y square. Now this is equal to limit t approaches to 0. Now substitute the value of x and y, which is minus t into t divided by t square plus t square, which is equal to what? Limit t approaches to 0 minus t square divided by t square plus 2t square, that is t square plus t square is 2t square. T square and t square cancel, which is equal to what? Limit t approaches to 0 minus 1 divided by 2. And what is the limit of minus 1 divided by 2? Is minus 1 divided by 2. And this is the limit. Okay. Now, similarly, you can find for the D part. D part is what? That you have to choose y is equal to minus x. So what will be the parametric equations? Parametric equations will become x is equal to t and y is equal to minus t. Okay. So just substitute the values x and y approaches to 0 and 0 along y is equal to minus xy divided by x square plus y square. Yes, 1 by 2. Yeah. Limit t approaches to 0 minus what is the value of x is t and what is the value of y is minus t divided by t square plus minus t whole square, which is equal to limit t approaches to 0, that is t square divided by t square plus t square. You can write limit t approaches to 0, t square divided by 2t square, t square and t square cancel. Limit t approaches to 0, 1 divided by 2. Okay, and 1 divided by 2, the limit is 1 divided by 2. Yes. Okay. Now the last part is about the parabola. E part, that the curve y t is equal to not. Oh yes, you can choose this one also. X is equal to minus t and y is equal to t, because the condition is that y is equal to minus x. So no problem, you can choose this one. If you choose this one, you will get the same answer. Okay. Limit t approaches to 0, this is minus into minus t into t divided by minus t whole square plus t square, which is equal to limit t approaches to 0, that is t square divided by t square plus t square, which is equal to limit t approaches to 0, t square divided by 2t square and t square cancel. Okay, so you can choose any parametric equation which satisfy this condition, y is equal to minus x. So it means either you can put with the negative sign with the x value or with the y value. Okay. Now come towards the E part. E part is for the parabola. For the parabola is for the curve parabola y is equal to x square. Now for the x square, if I choose x is equal to t, y will become t square. Okay, y will become t square. Okay, now if you want to change the another side, okay, if you choose y is equal to t, y is equal to t, if you want to choose y is equal to t, then x will become square root of t. Okay, so this is the difference here, because x and y have the difference. Okay, let me give you in detail. If here, if I put t, so y is equal to t square, because if I choose x is equal to t, y will become t square. Now if I put here t is equal to x square, it means I choose y is equal to t, so x will become square root of t. Okay, so you can choose any of this one. Now if I choose this one, so what will be the limit? Limit x and y approaches to 0 and 0 along parabola y is equal to x square minus xy divided by x square plus y square, which is equal to limit t approaches to 0. What is the value of x? X value is t. And what is the value of y? Which is t square divided by x value is t and y value is t square whole square, which is equal to limit t approaches to 0 minus t power 3 divided by t square plus t power 4. Okay, so what will become approaches to t into 0 minus t power 3, if I take t square common, 1 plus t square, this cancel with this one. So what becomes t approaches to 0 minus t divided by 1 plus t square. If you substitute the value, minus 0 divided by 1 plus 0, minus 0 divided by 1, which is equal to 0. Okay, so this is the limit how you can find from the parabola. The curve is a parabola. Is this clear? Okay, so this is about the limits. Now you say you find the limit. At what condition you say the limit does not exist? So there is a relationship between between the general limit and limits along smooth curve. Okay, so what is the relationship between these two limits? That there is a theorem. The theorem says that a part, that if you have any function, if for example f of xy is any function whose limit is L, as x and y approaches to some point which is x naught and y naught. Okay, then the function xy limit is L as x and y approaches to x naught y naught along any smooth curve, along any smooth curve. What does that mean? For example, you find the limit of a function and you get the limit of the function L. That means that if you choose any smooth curve means, for example, you choose y is equal to x square, y is equal to x power 2 plus 2x, whatever is the smooth curve. If you choose, okay, if you change the limits, the limit will be the same. The limit you find and the limit along the smooth curve will be the same. Okay, so this is the first theorem. The second part of the theorem says that if the limit fails, if the limit of the given function, for example f of xy, fails to exist as x and y approaches to any point along some smooth curve, or if the function has different limits as x and y approaches to some point x naught and y naught along two different curves, two different smooth curves, then the limit of f of x does not exist as x and y approaches to any point x naught and y naught. What is mean by this one? That for example, if you are finding the limit of any function at it give you infinity, it means the limit fails. If it means the limit does not exist. The second condition says that if you choose two smooth curves, okay, for example, I choose y is equal to x and y is equal to minus x, two smooth curves, okay, but for the both limits the limit is different, so it means the limit does not exist. Similar case you studied in calculus 101. You remember that you say that limit of any function, for example a plus, this is a plus of the function, okay, and limit along x a minus f of x, if the both are same, then you write that limit of the given function exist. You remember this one? That for example I write here 3 and this is 3. If the both are same, then you can say the limit is 3. If you say here this is equal to for example 4, and this is equal to 3, this is different, so you write here does not exist. You remember this one in calculus 101? Okay, this is exactly same meaning, that if you have two different limits, just like in the last example. In the last example you see that the limit of the function x and y approaches to 0 and 0, and the given function is minus xy divided by x square plus y square. A part along x-axis, the limit is 0. B part along y-axis is also 0. The C part along y is equal to x is minus 1 divided by 2. D part along y is equal to minus x, that is 1 divided by 2. And E part along y is equal to x square, we got 0. Okay. Okay. So now if I choose for the limit to be exist, all the values should be same, but you will find here two different numbers, three different numbers, 1 by 2, minus 1 by 2 and 0. Okay, so it means the limit x approaches to y, x and y approaches to 0 and 0, minus xy divided by x square and y square does not exist because limit x and y approaches to 0 and 0. For example, if I choose along x is x-axis, okay, minus xy divided by x square plus y square is equal to 0, and limit x and y approaches to 0 and 0 along y is equal to x, minus xy divided by x square plus y square is equal to minus 1 and 2 not same. Okay, so this is 0 and this is minus 1 by 2, so that means the limit does not exist. Is this clear? For the limit exist for any smooth curve you choose, the limit must be the same number. Okay, so this is the condition. For example, in the exam, if I ask you to check the limit of the function at two different points, okay, for example, I ask you to find it was the same, we can find the limit. Yes, when the limit is same, then you can say the limit exists and that is the limit. Okay, if they are same. Okay, if they are not same, in this case we have three different limits, 0, minus 1 by 2, 1, and this one, this limit, this one, and this one, three different limits. Okay, for example, you will find any function, for any function whose limit, if you whatever you choose, for example, I can give you one example. Limit x and y approaches to 0 and 0, and you have function x square y square. If this is a function, okay, so if you choose either x-axis, either y-axis, either y is equal to x, either y is equal to minus x, y is equal to x square, or any other smooth curve or any other curve. Okay, if you choose, the limit of this one is equal to 0. There must be the limit of this one is equal to 0. So in this case, you can say this function exists, this limit of this function exists, which is equal to 0. You can check. Okay, when you for check for the x-axis, it means x is t and y is 0. So limit t approaches to 0, which is equal to t square into 0, which is equal to limit t approaches to 0, 0 is equal to 0. For y, you can put y is equal to t. Okay, limit t approaches to 0, 0 into t square, which is equal to limit t approaches to 0, 0 is equal to 0. If you choose x is equal to t, y is equal to t, that means limit t approaches to 0, that is t square into t square, which is equal to limit t approaches to 0, t power 4 is equal to 0 power 4 is equal to 0. If you choose y is equal to minus x, that will give you 0, 0, and 0. Okay, so this is the function which limit you can say the limit exists and which is 0. So in the exam, if I ask you to find the limit at any 2 points, and at that 2 points the limit is same, you can say the limit exists. And this is the method to find the limit. Okay, is this clear?